Chapter 2, Polynomial, Session 1. Let's start. So, basically, polynomial is have a lots of things. Let's start with the degree, right? Well, let's start with the degree. In the polynomial, first thing that we need to learn is a degree. So, what is the degree? So, degree is nothing but the highest power of a polynomial. Highest power of a polynomial. For example, if I write down x cube minus x to the power 5 plus 9, right? So what is the highest power? 3? No, the highest power is what? 5. So the degree of this polynomial is nothing but the 5, right? For example, if I write down y square minus y power 3 minus y power 8, so what is the highest power? So highest power is nothing but the 8. So the degree of this polynomial is nothing but the 8. Here, if it is a 0, right, then what is 0? The highest power is 0, then it is called the constant term. How? If I write down 5x power 0, so power is 0 of any number, it becomes 1, so it becomes 5. So that is why if the degree is 0, it is called the constant term. Or if I say what is the degree of 5, you simply say it is 0. Okay. Now if degree is 1, it is called the linear polynomial. Now degree is 1 means what? It is, in general, I can write down ax plus b, where a is not equals to 0. Where a is not equals to 0. Why a is not equals to 0? Because if a is equals to 0, for example, if a is equals to 0, then 0 into x plus b, it becomes, see, x into 0 is nothing but the 0, so 0 plus b is nothing but the b. So b becomes the constant term. So that is why this is the required condition, that a is not equals to 0. Similarly, if it is a degree 2, then it is called the quadratic polynomial. So in general, how can I write down ax square plus bx plus c, where a is not equals to 0, right? If a is equals to 0, assume that a is equals to 0, then this term becomes 0, and we are remain only with the bx plus c, and bx plus c has a degree 1, and this is going to be the linear equation, right? Now 3. So for the 3, what I can write down is ax cube plus bx square plus cx plus d. Okay. So here a is not equals to 0 is a compulsory condition in each and every polynomial. Why? Because if a is becomes 0, so this term is eliminated and this term is remain, and here the power is 2, so degree is 2, and this becomes the quadratic polynomial. So that is why this is compulsory condition, that a is not equals to 0. Now if it is a biquadratic polynomial, right, so what I can write down, it is nothing but the ax power 4 bx cube plus cx plus d, and where a is not equals to 0, because if a is becomes 0, then the highest power is 3, and that is going to be the cubic polynomial. That is why this is the compulsory condition, right? So here we can see, if it is a 0, constant polynomial; if it has a degree 1, linear polynomial; if it has a degree 2, quadratic polynomial; if it has a degree 3, cubic polynomial; if it is a degree 4, it is called the biquadratic polynomial. If the degree is 1, constant; if the degree is 0, constant; degree is 1, linear; degree is 2, quadratic; degree is 3, cubic; and degree is 4, it is called the biquadratic polynomial. Now let's move. Another thing that we need to learn in the polynomial is term, variable, and the coefficient. So what is the term? If any polynomial has a one term, it is called the monomial. If it has a two term, it's called the binomial, and if it has a three term, it's called the trinomial. For example, here if I only write the x cube, x to the power 4, right? It's a comma. These are the two different things. Two different terms. So this is called the monomial. But if I write down x plus 2, or you can say x minus 3, or you can say y minus 4, so these are the binomial because this has the two terms. That this polynomial becomes the form with the two terms. Here, if it has a three terms, then what is the it is called the trinomial. For example, ax plus bx square plus 9, right? So this has a first term, this is the second term, and this is the third term, right? So if it is become with the third term, it is called the trinomial. Okay, now variable, right? What do you mean by variable? That we already learned in the standard 8. See, still I'm going to repeat here. Variable means vary. Variable means vary, right? If I say you have X chocolate, your friend might say you might have the 5 chocolate. Another friend might say you might have the 1 chocolate. Another friend say it might have a 10 chocolates. So the number of this value varies from person to person. That is why it is called the variable. And here we can take the variable a, b, c up to z. We have this much amount of variables, right? So if it has a one variable, it might have a two variable, and so on and on and on and on. Now what is the coefficient? It is simple. If I write down ax square plus bx plus c, right? So the number, the constant number which is multiplied with the variable is called the coefficient. So here the coefficient of x square is a, coefficient of x is b, and this is the constant term. Once again, if I write down here 5x minus 3x square plus 8, right? Then what is the coefficient of x? Coefficient of x is 5. What is the coefficient of x square? See, this is the important. What is the coefficient of x square? We need to consider here the sign on also. We have to consider here the sign also. That is why the coefficient of x square is nothing but the minus 3. Okay? If I write down here minus 3x cube plus 5x square. So what is the coefficient of x cube? It is nothing but the minus 3. What is the coefficient of x square? It is nothing but the plus 5. Okay? So you need to consider the sign. Okay, this is the theory that I already explained you in the previous two slides. Okay, and let's check polynomial in one variable. Polynomial in one variable. So we use letter x, y, and z, etc. to denote the variable in general, right? You can also take the a, b, c, d, whatever, but in general we use the x, y, and z for the variables. Notice that 2x, 3x, minus x, minus 1 upon 2 are the algebraic expressions. See here. Here it is, might be with the x by 2, right? So these are the algebraic expressions. All these expressions are of the form constant multiply with the x. This is the multiplication sign. So it is the constant multiply by x. Okay? Now suppose, how you can say that? See, this is the variable. If you consider the 2x, right? So here x is the variable, and 2 is the constant. So it is nothing but a constant multiply by the variable x. Now suppose we want to write an expression which is a constant into a variable, and we do not know what is the constant is. In such a cases, write the constant as a, b, and c, etc. So expressions will be like ax, say. See, when we have to write down in general, this is here in this topic we're talking about the, if we have to write down the expressions in general. So how? That we see that if I write a general expression of quadratic equation, that is ax square plus bx plus c. So here a is a constant term. A is a constant term with the variable x. Okay. So in such cases, write the constant as a, b, c, etc. Okay. Now you are familiar with the algebraic expressions like 2x, x square plus 2x, x cube minus x square. Okay, here tell me one thing in this equation. What is the coefficient of x square? See, coefficient of x square is nothing but the minus 1. Why? Because here the minus. Okay, what about the coefficient of x? So coefficient of x is 4. What is the coefficient of x cube? Coefficient of x cube is 1. Okay, now note that all the algebraic expressions we have considered have only a whole number as an exponent of the variable. Expressions of this form are called polynomial in one variable. Right? See one thing, algebraic expressions we have considered here has only a whole number. Only a whole number. For example, if I write down here 1 upon x to the power 1 upon 2, can I say this is the polynomial? Can I say this is the polynomial? No, right? Because the power is a rational number. The power here must be a whole number. The power here must be a whole number. If I write down a square root of x plus 9, then can I say this is the polynomial? Still no. Why? Because in the first chapter we learned that square root of x, that means x to the power 1 upon 2. Okay. Now let's move ahead. So here one thing that you need to remember is, if it is a polynomial, the must condition is the degree, or you can say the power, the must be a whole number. It must be a whole number. In the polynomial x square plus 2x, the expressions x square and 2x are called the terms, right? Here x square and 2x are called the term. So this is becomes with the 2 term, and if it is formed with the 2 term, then it is called the binomial, right? That we see in the chart, that we already see in the chart. Similarly, if it is 3x square plus 3y square plus 5y plus 7 has a 3 terms, namely 3y square, 5y and 7. 3y square plus 5y and 7. Can you write the terms of the polynomial? Simple. How you can write down? This is the first term, minus x cube. The second term, 4x square. The third term, 7x. And the fourth term is minus 2. Okay. So degree of the polynomial, that I already taught you, that highest power of the polynomial is called the degree of the polynomial. Here, what is the highest power? 3. So the degree is 3. What is the highest power here? 4. Here is the highest power is 4. So the degree is 4. The types of polynomial. The linear polynomial, degree 1, right? That we already see in the chart. In general, what I can write down? Ax plus b is equals to 0, where a is not equals to 0. Quadratic polynomial of degree 2, ax square plus bx plus c, where a is not equals to 0. Cubic polynomial with the degree 3, ax cube plus bx square plus cx plus d is equals to 0, where a is not equals to 0, or you can say x cube is not equals to 0, right? Here, the thing is, a must not equals to 0. The biquadratic polynomial with the degree 4, so in generalize, this is the a is not equals to 0, and ax power 4 bx cube plus ax square plus dx is equals plus e is equals to 0. Okay. Now see the sum of exercise 2.1. Which of the following expressions are the polynomials in one variable which are not? State the reason for your answer. So, can I say this is the polynomial in one variable? Yes, this is the polynomial in one variable. Can I say this is the polynomial? Yes. Why? Because root is 2. The power of variable is a whole number. That is why it is called the polynomial in the one variable. Can I say this is the polynomial? No. Why? Because square root of t. So t to the power 1 upon 2. So this is not the variable. Right. So consider it is not a variable. In same manner this, it is 2 upon y. That means 2 into y power minus 1, and minus 1 is not a whole number. It is integer. right? So that is why we can say this is also not the variable. Now, can I say this is the polynomial in one variable? No, right? This is not the polynomial in one variable. Why? Because it has a 1, 2 and 3 variable. It has a 1, 2 and 3 variable. So this is not the polynomial. This is not the polynomial in one variable. Okay, this is not the polynomial in one variable. Okay, now write the coefficient of x square in each of the following. X square's coefficient. So what is the coefficient of x square here? 1. What is the coefficient of x square here? It is minus 1. What is the coefficient of x square here? See, other than x square, whatever is there you have to write down. So here it is pi by 2. Okay. Here what is the coefficient of x square? See, x square is not here, right? If you multiply x square with the 0, it becomes 0. So plus square root of 2x minus 1. So what is the coefficient of x square? It is nothing but the 0. If it is nothing is written, then it is, but obvious it is a 0. Okay. So that's it for today, right? This is the very much important chapter as far as your SSC is concerned. I think each and every chapter of the standard 9 are the base to solve the equations or solve the sums into the SSC. So I hope you do this chapter's theory very well so that you faces a very small number of problems while you be in there in the standard 10. Okay, so bye bye, work hard, meet into the next lecture. Till then, bye bye.